observed that when we try to find out the value of sine inverse half, it is equal to many angles, say pi by 6, 5 pi by 6, 13 pi by 6, minus 7 pi by 6 and so on. And that way it is a difficulty that can we define sine inverse half as a function or not. To overcome this difficulty, we will discuss with the help of the graph of sine theta and hence the graph of sine inverse x. So first of all, though already you have done in your class 11, let us see the graph of sine theta. Do we know that normally to the horizontal line we define x-axis and to the vertical line as y-axis. But here for a certain particular purpose, I am calling this horizontal line as theta axis and the vertical line as x. That is, for the values of theta, what is the value of sine theta? We define it like this: x is equal to sine theta. Now draw the graph of sine theta. For that I choose the angle 0, pi, 2 pi, minus pi, minus 2 pi. Let us divide them like this: pi by 3, pi by 6, sorry, and pi by 3, 30 degree, 60 degree, 180 degree, and so on. Similarly on this side, minus pi by 6, minus pi by 3, and so on. Now what is the domain of sine theta? Domain of sine theta is that theta can be any real number. We can take any angle 0, pi, 2 pi and so on, and similarly on the negative side. And what is the range? That is the values of sine theta. You know, sine theta lies on between -1 and 1. So on this axis, traditionally so-called y-axis, where I have particularly marked x, we can go only till 1 and -1. And let me mark very specially half and -half here. Now what is the value of sine 0? 0. What is the value of sine 30 or sine pi by 6? Half. What is the value of sine pi by 2? Sine 90 degree, it is 1. What is the value of sine 5 pi by 6 or 150 degree? It is again half. And what is the value of sine pi? It is 0. So you get the graph like this. And similarly, if we find the value of sine 3 pi by 2, it will be -1, and sine 2 pi, it will be 0. So you get a graph like this. And on the negative side, you know, sine -30 is -half, sine pi by 2 is -1, sine pi will be 0. So graph can be extended like this, and so on. So this is the graph of sine theta. I repeat, sine 0 is 0, sine 30 degree is half, sine 90 is 1, sine 90 is 1, sine 150 degree is half again, and so on. And even if I produce here, the value of sine 390 is half again. And similarly on this side. Sine minus 390 degree will be half again. Now let us draw a line parallel to theta axis through x is equal to half. What do you find? That when we draw a line parallel to theta axis, and on x-axis at x is equal to half, it intersects the graph at many points, and the corresponding angles are 30 degree or pi by 6, 150 degree or 5 pi by 6, and 390 degree or 13 pi by 6. Similarly, on the left side, it intersects at this is minus 210 degrees, and so on. So there are many angles for which the value of sine theta is half. Now let us translate the same for sine inverse half. So draw the graph. With the help of this graph of sine theta, let us draw the graph of sine inverse x. You already have this graph with you. Now, to draw the graph of sine inverse x, let sine inverse x is equal to theta. So now on the horizontal axis, I'll take x, the independent variable, and on the vertical axis, I'll take theta and draw the graph. For x is equal to 0, what is the angle whose sine is 0? You look at the graph of sine theta, sine 0 is 0, so sine inverse 0 is 0, then sine inverse pi, sine inverse 0 is pi because sine pi is 0, and 2 pi, similarly it could be minus pi, and minus 2 pi. So sine inverse 0 is pi, 2 pi, and so on, and negative pi and negative 2 pi. Now let's see what is the value of sine inverse half. That is, what are those angles whose sine is half. So you know from here that sine 30 degree or sine pi by 6 is half. So sine inverse half is pi by 6. It is also 150 degree or 5 pi by 6. And what is the value of sine inverse 1? It is pi by 2. So if you draw the graph, it will take this shape. This portion from sine theta will go to this way, and similarly, if we proceed, it will take this shape and intersect this vertical axis at 2 pi, and on the negative side, it will take this shape. Sine negative pi by 2 is negative 1. Sine negative half, sine inverse negative half is negative pi by 6. And so on like this. Now look at it again. Again let us discuss the value of sine inverse half. That is, what are those angles whose sine is half? You find here, draw a line parallel like this. So you find it is pi by 6, it is 5 pi by 6, it is 13 pi by 6, it is minus 7 pi by 6, and so on. So there are many angles whose sine is half, or sine inverse half corresponds to many angles. How can you remove this difficulty? Just confine yourself to this portion of graph, where x of course lies between negative 1 to 1, but theta lies between negative pi by 2 to pi by 2, both inclusive. Just look at this portion carefully. Do you find that to each value of x, there is a unique angle? Say for example, again, for sine inverse half, you have only pi by 6. For sine inverse 1, you have pi by 2. For sine inverse negative 1, you have negative pi by 2. So for each value of x, there is a unique angle. That is, to each x, there corresponds a unique angle. So we can say that yes, sine inverse x can be defined provided it lies between negative pi by 2 to pi by 2. And to this we call principal value branch. So what is the principal value branch of sine inverse x? The principal value branch of sine inverse x is negative pi by 2 to pi by 2, both the boundaries included. And similarly, we can discuss about the principal value branches of cos inverse x, which will be 0 to pi, tan inverse x, which will be negative pi by 2 to pi by 2, but boundaries are not included, and so on. Thank you.